All right, this is our video for complex conjugate theorem. We started off by talking about this basic equation right here. If you were to solve this, you would subtract 4 to both sides, and you'd have -4, and then you would square root, and you'd have x equals plus or minus the square root of -4. Now, there's no real number solution to that problem, so this is going to be an imaginary solution. -4 is -1 times 4, so I'm taking the square root of each of those individually. The square root of 4 is 2, and the square root of -1 is I. So somewhere on your notes, write down that the square root of -1 is I. And then we have a corollary to this. If you imagine squaring both sides, if you squared the left side, it would cancel out the square root, leaving me -1. And if we squared the right side, it would give me I squared. So both of these statements are true, and we're going to use this one, the second one, in our math for the lesson. And then right here, it talks about conjugates. Conjugates are, so for example, this is a pair of conjugates. They're the same, but they have opposite signs. Other conjugates that we've seen before would be if there was a real number portion with an imaginary. These are complex numbers. See, everything's the same, but the signs in the middle are opposite. Those would be conjugates of each other. So we'll be talking about that. So in this first problem, we're given two roots, 3 and 2i, and we're being asked to find a third degree polynomial that has those roots. Now, third degree means that your leading term is going to be to a power of 3, and it's also going to mean that the equation has 3 roots. Well, I've only been given 2 roots, and that's where the conjugate complex numbers come in. So when I solved this equation up here, it gave me 2 answers, a positive 2i and a negative 2i. So these complex or imaginary roots are always going to occur in pairs, the positive version and the negative. So if I'm told that I have positive 2i as a root, I can also assume that I have negative 2i as a root as well. So there's my 3 roots, 3, positive 2i, negative 2i. So to get my polynomial, I'm going to start off with my factored form. So if 3 is a root, its corresponding factor is x minus 3. For 2i, it's x minus 2i, and for negative 2i, it's x plus 2i. Now we're going to make our math easier by multiplying the conjugates first. This is a difference of 2 squares situations, but I'm going to show you FOIL to show you the math behind that. So double distribute, I'm going to distribute this x first. So that gives me x squared plus 2ix. And then I'm going to distribute the negative 2i. So that's negative 2ix. And then minus 4i squared. So notice that the middle terms drop out. And then for the negative 4i squared, I'm going to use this fact up here that we talked about. Anytime you see an I squared, you want to replace it with a -1. So that is -4 times -1, which is positive 4. So now this whole thing simplifies to x squared plus 4. And notice how there is no more I there. And so now I'm just going to double distribute here, distribute my x. So y is equal to x cubed plus 4x. Distribute the -3. And this is a correct answer. You can also write it in standard form if the order matters to you. So both of those are correct answers. So I want you to pause the video and I want you to look at the second problem and compare it to the first one and think for a minute about how the setup is different here and what the problem is asking me for compared to this problem that we just finished doing. Okay, so hopefully here's what or something. Miss Fadia's talks, take 2. This is what I was hoping you would notice. In the first example, we were given roots, we factored formed, got standard form. Here we're going backwards. We're starting in standard form, we need to get to factored form, and then we need to get to the roots. And I'm given one root to start with. Now in our previous lessons, we would take this root and we would do synthetic or long division to start our factoring. But watch what happens if I were to try that here. And I'm going to erase this. This is not correct, so please don't write it down. Just watch. If I were to start my synthetic division and do this round of multiplying, I would put -5 here. I would add, that would be 3 minus 5i. Multiply it by -5i again, and this math is going to get ugly really quick. So this is not going to work. Polynomial division, synthetic or long, is not going to work with i's in it. So here's what we're going to do instead. We need a way to get rid of I. Well, that's what happened right here. When we multiplied these conjugates together, it gave me the x squared plus 4 with no more I in it. So we're going to do that here. If we have -5i as a root, we know that we also have +5i. So in factored form, those are x plus 5i, x minus 5i. Multiply those together, x squared minus 5ix plus 5ix minus 25i squared. The middles cancel. -25, substitute -1 for the I squared, that's going to be a +25. So now I have this factor with no more i's in it that I know is a factor of this polynomial. So now I can set up my polynomial division to keep solving. Here's the situation though. Synthetic division does not work with a quadratic factor. It works only for linears. So you have to do long division on this one. And since I'm missing the x term, I'm going to use 0x as a placeholder. Now for the record, I think you could do grouping here, but I'm going to show you long division because in the next problem we're going to use long division. I'm not sure you can do grouping there. So I just want you to see another example of long division, but please feel free to do grouping if you want to. So I recommend you pause the video and do the long division by yourself first. But if you're already watching at this point, I'm just going to do that quietly for a minute and you can just check your work with mine. So my remainder is 0, which is good. That means my math was correct because I already knew that this x squared plus 25 was a factor and therefore divides evenly into the polynomial, which means my remainder is 0. So here is my final factor. So this is my factored form. I already know that the two roots from this one are positive and -5i. And the root for this one is a -3. So then I want you to pause the video and try this problem. All right, so for this problem, I started with this. I know that if I have +3i, I also have a -3i as a 0. So I made factors of them. And if you were to FOIL that out, remember, just like here, the middle terms would cancel. Your last term would turn positive because you're substituting -1 for the I squared. and you would have x squared plus 9. So take a minute and check my long division with yours. Pause the video if you need to. Now you'll notice that the quotient up here is not linear like in our last problem. This is a quadratic, so we have to do one more round of factoring here. So I'm going to do my cross method. What multiplies to 10 and adds to -7? It's -5 and 2. A is 1, so this is my shortcut method. So here are my factors. X minus 5, x minus 2, and then I had the original ones. So my roots are 5, 0, 2, 0, and you're done.